Yeah, today in this class we are going to talk about threads. In previous class we have studied about a process. See what is a process. See what are the various process states, and what is a process scheduling, and at the same time what are the various queues, that is scheduler queues, and what are the various inter-process communication mechanisms. At the same time, in the inter-process communication, we are going to use message passing and at the same time shared memory. In the message passing, how we are going to pass the message between two processes is done by using the direct and indirect, direct communication or indirect communication, or as well as synchronous or asynchronous or buffering. All those things we covered in the topic called as process. Now in this class we are going to talk about thread. See what is a thread, what are the various types of threads, and what is a multi-threading models, and at the same time what are the various multi-threading model techniques, what is multi-core programming, and at the same time what is implicit functioning, implicit testing, like that. Okay, all those things we are going to talk in this threads concepts. See, before going to see thread, see what is the basic definition of thread. Okay, so a thread is a we can say a process is a collection of threads. Okay, if you take a process, in that process what we have is it is nothing but it is a collection of thread. Collection of threads we can call it as a process. Okay, a process is contained inside a process. A thread is contained inside a process, and different threads in the same process share the some resources. That means what is the definition of thread is? Thread is nothing but collection of threads is a process. For example, if a process use some of the resources is nothing but what are the threads in that process, although threads also use the same resources. Okay, here a thread is contained inside a process. That means a process we have in a process we have a thread and a different threads in a process. Okay, what are the threads that are present in the process? Those threads are share some common resources. Okay, next, one more definition of thread is a basic unit of CPU utilization. Okay, it means, see, whenever a process is executing, in the sense the threads that are present in the process also is executing. A process is executing in the sense it will utilized by the CPU. Okay, so we can say, that's why we can say thread is a basic unit of CPU utilization. See, at the same time here a process, as we know that process is a process contains program counter as well as stack, and at the same time registers. Okay, so a thread will also contain the same thing, that is registers and stack area, and at the same time program counter. Next, one more definition of thread is a thread is a flow of execution through the process code. Okay, we can say thread is a flow of execution. Okay, that means when a process is executing, in the sense all the threads in the processor is going to be executed. Next, one more simple definition of thread is, we can say thread is a lightweight process. Okay, so thread is a lightweight process. So this is the basic definition of thread. If you see the representation of this diagram, here a process may contain multiple threads. Here thread 1, thread 2, thread D. See here, this is a thread. That means if you take a process, in that process we have various threads. We can say thread is nothing but a process may contain multiple threads. Okay, see here, this is one more representation of the threads. We have single threaded process, at the same time multi-threaded process. Here single threaded process means only we have one thread. Okay, whereas multi-threaded process means we have multiple threads. Here we have three threads. Here what is a thread? Where thread contains is process. If you take the process, we have code area, data area, and stack area, and register. At the same time here also, if you take the multi-threaded process, here also same register area, stack area, and at the same time data area and code area. Okay, here a process may contain single thread. Here a process may contain multiple threads. Okay, so this is the representation of the threads, that is single threaded process or multi-threaded process. Next, coming to, there are two types of threads, that is single threaded process or we can say single thread, or second one is multi-thread. See, what is the major purpose of the single thread means, it has a single thread of control. Here if you see, here only we have one thread, okay. At the same time, see, one more thing is it allow the process to perform only one task at a time, okay. Here if we have only one thread in the process means we are going to perform only one task at a time. Why? Because here in this process we have only one thread, okay. Whereas coming to multi-thread, okay, multi-thread or multi-threaded process, it has many threads, okay. If you see this diagram, we have many threads. Here many threads in the sense we have three threads, okay. At a time we are going to perform three tasks, okay. Here in the first diagram we are going to perform only one task, whereas in the second representation, that is multi-threaded process, we are going to perform three tasks at a time. Why? Because here we have three threads, okay. So that is simultaneously we are going to execute different tasks. So different task means that depends upon the different threads, okay. If we have three threads, we are going to perform three tasks, or five threads, we are going to perform five tasks, okay. So this is the basic difference between single thread and multi-thread, okay. Whereas single thread we have only single thread process, we have only one thread only. That means if a process contain only single thread, we can say it is a single threaded process, okay. In that one we are going to perform only one task at a time. Whereas if a process contain multiple threads, we can say that is a multi-threaded process. In that one we are going to perform multiple tasks, that is different tasks simultaneously, okay. So this is the single thread and multiple thread. See, next, whereas coming to benefits of multi-threaded programming, okay. What are the various benefits of multi-threaded programming? See, first one is responsiveness, second one is resource sharing, third one is economy, next fourth one is scalability. See, what is meant by responsiveness, okay. See, responsiveness means, here responsiveness is nothing but responsiveness to the user. That means if user is working with a process or multi-threading multiple threads, due to some reason one thread may fail, okay. For example, if one thread may fail means, then the remaining threads take the responsibility of that failure thread, okay. So and execute a task, okay. For example, there are multiple threads are executing. If one thread fails means there is one more thread will take the responsibility of the failure thread and execute the process. Then there is no effect of this failure thread to the user. That means if one thread fails means automatically that failure thread will be executed by the one more thread, okay. So user can perform his process successfully without waiting, which gives quick response to the user without consuming more time, okay. Here responsiveness in the sense, if there are multiple threads are there, among the multiple threads, if one thread fails, okay, so one more thread will take the responsibility of the failure test and executed that particular thread. This is nothing but responsiveness, okay. Next, second one is resource sharing. See, if one process is utilizing the resources and all the threads present in also utilize the same resources, okay, more resource sharing helps to perform more number of tasks simultaneously, okay. That means if we are sharing more number of resources, okay, automatically it will it will help for executing the multiple tasks at a time. See, next one is economy. See, what is meant by economy? See, economy means it is nothing but cost, okay. The drawback of economy is process resources or cost. Generally, process resources are, we can say it is very fast. Even though there exist costly resources, we can perform multiple tasks concurrently. This means this is one of the benefit of multi-thread programming, okay. Next one is scalability. See, what is meant by scalability? Within less amount of time, we can perform multiple tasks in parallel by using multi-threaded programming. We can say it is a scalability. That means by using the scalability concept only, we are going to perform in the multiple task by using the multiple threads, okay. So these four are the major benefits of multi-threaded programming, okay. That means if we are using the multi-threaded process, what are the various benefits is nothing but, first one is responsiveness, second one is resource sharing, and next one is economy, next one is scalability, okay. So next one is, next coming to multi-core programming. See, what is meant by multi-core programming? See, here multi-core programming is nothing but, in multi-core programming we are going to use multiple cores or multiple processors instead of single core, okay. Here we are going to use multiple cores or we can say multiple processors, okay, instead of single core. In this multiple processor, in this one what will happen is multiple processors are embedded in a single chip and it will act as a single processor, okay. See, if you see that multiple processor, we are going to use only single processor that are embedded in a single chip. The reason for using multi-core is, if we are use multi-core, we can execute more than one task concurrently. If we use single core, we can execute only single task at a time, okay. By using multi-core, we are going to achieve the concurrency also, which means executing multiple tasks simultaneously, okay. Here the operating system with a single processor work differently when compared to the operating system comparing multiple processors, okay. Here if you see this diagram, here two cores are there, core 1 and core 2. We are going to execute multiple tasks, T1, T2, T1, T3, T1 again T3, like that. Here T2, T4. Here we are going to, that means a parallel execution of the different processes by using the multi-core within a single chip, okay. Here we have only single chip, we are going to use a single chip. With that single chip, we are going to use multiple processes, okay. Next, coming to challenges. What are the various challenges in multi-core system, okay. If you come to the various challenges, first one is identifying the tasks, and second one is balance, and third one is data splitting and data dependency. Next one is testing and debugging. See here, identifying the tasks, that means here we are going to divide the tasks, okay. That means we can say division of equal distribution of the task. Here task means we can say thread, okay. Next, after that one, we are going to splitting the data associated with each task, that means each thread. Next, to at the same time, here we are going to, that is nothing but data splitting. At the same time, here we are going to performing the synchronization, that means ensure the synchronization whether it is performing or not, okay. Synchronization means the two threads which are dependent or executed by assigning the cores to the operating system. At the same time, next one is data dependency. The data is accessed by the task must be examined for a dependency between the two or more tasks, okay. Here first one is identifying the task, that means division of task, we can say simply division of task. Second one is balancing. Balancing means assigning the task to the particular processor or particular core. Next one is data splitting, we can say the execution of the task by the core. Next one is data dependency, okay. We can say data dependency means whether the particular task is executed by the particular core or not. Here in this one, we are going to check whether the particular task is executed by the particular core or not. Next one is testing and debugging. Here testing and debugging means finally we are going to debug if there is, for example, particular task is executed by the particular core, whether it is executed perfectly or not, okay. In this that is nothing but debugging. If there is any debugging occurs, again we are going to give the same task to the same processor or same core, okay. These are the various challenges in the multi-core programming, okay. We can say multi-core system, okay. So next, coming to the different types of threading models, okay. Basically there are two types of threads, that is just now we have seen, that is single thread and multi-thread. Here, whereas coming to, this is one more category of threads, okay. That is kernel level thread, and the next one is user level threads, okay. That is previous we have studied just now, that is single threaded process, multi-threaded process. In that one we have single thread, and second one is multiple threads. Whereas here, completely what are the different types of threads, okay. Generally we have two types of threads, that is kernel level thread, and next one is user level thread, okay. So here, what is user level thread, what is kernel level thread, okay. Here user level threads are placed above the kernel level threads and does not require any support from the kernel. It means here what will happen is, first of all we have kernel thread, again after that we have user level. That's why we can say user level threads are placed above the kernel level. And here what will happen, before we have kernel level, after that we have a user level. Okay, here the thing is, it will not require any support from the kernel. That means user level thread is different, at the same time kernel level thread is different. Whereas kernel level threads are supported and managed by the operating systems. Okay, why? Because we have first of all kernel thread and then user threads. See, user level threads are not interacting with the kernel level threads, whereas kernel level threads are supported or interacting with the operating systems, such as whether it is Linux or Windows or XP or whatever it may be. Okay, ultimately here what will happen is the relationship, there is a relationship exists between the user level threads or kernel level threads. See, how we are going to interacting the user level threads or kernel level threads, or we can say multi-threading models. See, what are the various multi-threading models? Okay, here first one is many to one, and the second one is one to one, and next one is many to many. Okay, these three are the various multi-threading model techniques in which how we are going to represent how the user level threads or kernel level threads are interacting with each other. Okay, whereas if you take the first one is many to one, this is one more model. Here many user threads are there, only one kernel thread is there. Okay, here these are the user thread. Many user threads means here we are representing 4 user threads, here 3, only one kernel thread. Okay, here many user level threads all are mapped onto a single kernel level thread. Okay, that means all the user threads are mapped to a only one kernel level thread. Here thread management is handled by thread library in user space, which is very efficient. Generally thread management we are going to in order to perform the thread management, for that one we are going to use the thread library. Okay, see what is the thread library we are going to see now. Okay, if one more thing is, if a blocking system call is made, then entire process block, even if the other user thread would otherwise able to continue. Okay, here what will happen is, if one of the thread will fails, okay, remaining threads will take the responsibility of the execution of the that particular thread. Why? Because here many user threads are there, here only one kernel thread. Okay, see all the user threads are executed by the single kernel level thread. Okay, this is many to one. Next one is one to one. Okay, here only one user thread and at the same time one kernel thread. Okay, in one to one, each user level thread maps to one kernel level thread. Okay, here one user thread maps to one kernel, one user thread maps to one more kernel, again one user thread maps to one more kernel, at the same time one user thread maps to one more kernel. That means here we have individual user threads, all the individual user threads are mapped to individual kernel threads. Okay, here one more thing is all the threads are run parallelly. Okay, here the main drawback is, along with the user thread, kernel thread should be created. Okay, for example, if one more user thread is created, in order to execute that user thread, definitely we are going to create one more kernel thread. Why? Because each here it is a one to one. Why? Because if we have user thread, definitely in order to execute that user thread, we have definitely one kernel thread. Okay, so we can say it is a one to one. Here next one is many to many. What is meant by many to many? Here many to many means many user threads and many kernel threads. Okay, many user threads and many kernel threads. Okay, here what will happen is, if you all the here how many user threads are there? We have 4 user threads are there. Here 3 kernel threads, 3 kernel threads are there. Okay, that means we can say many to many. Many to many in the sense, for example, here 4 user threads are there. Here only 3 kernel threads are there. Okay, no need to have 4 kernel threads. Why? Because here we have many kernel threads are there. See here, for example, if you see this diagram, we have 3 kernel threads. These 3 kernel threads is executed the 4 user threads. That means this 4 user threads can be executed by the 3 kernel threads. No need to have again here 4 kernel threads. Why? Because if for example, this user thread is executed by the particular kernel thread, okay, in order to execute a single user thread, we need only one kernel thread, okay, but this representation means many to many. That means many user threads may use many kernel threads, okay. For example, this is user thread. This user thread can be executed by the this kernel thread or this kernel thread or this kernel thread, okay. Again, second one, this is user thread. This user thread can be executed by the any one of the kernel thread, like that. Third one also, that is one more user thread. This user thread can be executed by the any one of the kernel thread. That is many to many. Here, many user threads is interacting with the many kernel threads, okay. This is the representation of the many to many. See, next one is what is the difference between process and thread, okay. See here, just now in previous chapter we have studied about the process. Now we have learned about the thread, okay. We can say process is a heavy weight or we can say resource intensive, whereas thread is a lightweight, okay. We can say thread is a lightweight, taking lesser resources than process. It means whereas process will utilize more resources, thread will use less resources. Why? Because a process may contain multiple threads, okay. And next one is what is the process is switching. Process switching need interaction with operating system, okay, whereas thread switching does not need to interact with the operating system. That means if a process want to interacting with the another process, that means switching, at that time definitely for that process we need operating system, whereas in threads we don't have any we don't need any operating system. Why? Because threads, where the threads is inside the process, so in order to move perform the moving of different threads, there is no need for the use of the operating system, okay. Whereas next one is in multiple processing environment, each process execute the same code but it has own memory and files, okay. Here, whereas threads can share the same set of files or different process. And the next one is if one process is blocked, then no other process can execute until the first process is unblocked, okay. That means if your process is executing, if that process is blocked, then no other process can execute until that first process is unblocked. That means after completion of the first process only, then next process will execute. While in threads, while one thread is blocked and waiting, and second thread in the same task can run. That means here threads, if one thread is failed, at the same time it will waiting. If it is waiting state, there is no need for wait for the failure thread, okay. That means the second thread will be executed. Whereas in multiple processes, without using the threads, use more resources. That means here we are using the more resources, here we are using the less resources. That means in threads we are using less resources. Whereas in process, in multiple process, each process operate independently of the others. That means we have different processes, okay. All the processes can work independently. Whereas threads, one thread can read, write or change another thread's data, okay. That means here if you have one thread, that thread can read or we can say write or change another thread's data, okay. But in the process it will not like that, okay. So this is the difference between process and thread, okay. Next one is thread libraries, okay. Next concept is thread libraries. See, what is meant by thread library, okay. Generally thread libraries we are going to implement either in user space or kernel space, okay. That means user level thread or kernel level thread, okay. At the same time, the user space involves API functions implementing slowly within user space with no kernel support. If just now we have studied, we said like no, in user space we are not involving with the user level threads, we are not interacting with the kernel threads, okay. Whereas here that's the same thing only we have studied, we are going to discuss here. The user space involves API functions implemented solely within user space with no kernel support. Here we don't have any kernel support, whereas in kernel space involving system calls require a kernel with thread library supports, okay. In the kernel space we are going to use definitely with the support of the operating system. See here, what is the definition of the thread library? Means thread library provides programmers with API for creating and managing threads. Okay, if the threads are created and managed by the programmers, then we can say it is a thread library. Okay, so what is the thread library? If threads are created and managed by the programmers with API, that means if a programmer will take with the help of the API for creating the threads or managing the threads, we can say it is a thread library. Okay, so what is meant by thread library? Thread library is nothing but if a programmer will create and manage the threads with the help of the API, then we can say it is a thread library. Okay, generally we are going to implement the thread libraries in two ways, that is first one is user space and kernel space. Whereas user space there is no interaction with the kernel, whereas kernel will take the help of the operating system. Okay, so what are the various types of thread libraries? Here generally we have two types, pthread libraries, or we can say Windows 32 thread library. First one is pthread library. See, in this we can say P means POSIX, or we can say POSIX pthread library. Okay, POSIX pthread library or pthread library. In Unix operating system, a thread is created by using function called pthread create. We are going to use the function called pthread create. So in pthread create contains some arguments like pthread id and pthread attributes. Pthread id is used to uniquely identify a thread, whereas pthread attribute consists of a stack area, some heap area, and local variable or global variable. Here majorly in POSIX pthread library, we are going to use some functions such as pthread create, pthread exit, and at the same time pthread kill, and at the same time pthread join. Okay, how we are going to create the POSIX thread is by using the function called as pthread create. Okay, by using this function only we are going to create the pthread library. Here we are going to use different functions, that is pthread exit or pthread kill, or we can say pthread join. Okay, see what is meant by pthread exit. Okay, see pthread exit, it is used to terminate the current thread and return its exist status to other waiting thread if any. Okay, it means it is going to terminate the whatever thread is executing currently, and it will return its exist status. That means it is going to be it's completed its execution, and I am going to exit that thread, and at the same time it will give chance to the another thread. Okay, if any. That is the purpose of pthread exit. And next one is pthread kill. See what is meant by pthread kill? Pthread kill is used to send a specific signal to the specified thread. That means the thread which is going to be ready to executed by the process. Okay, that means we are using this function, that is pthread kill, that it is used to send a specific signal. That means you are going to take the responsibility for execution. That means it will send signal to the specific thread. If there is one thread, it will send signal that you are ready for execution. Why? Because there is the thread which is executed by me is going to be exit. Okay, next I am going to give chance to you. Okay, like that it will send some signal to the specific thread. That is the use of pthread kill. Okay, so next one is pthread join. See what is meant by pthread join? Here pthread join is used to wait for a termination of some other thread. Okay, see it is going to be wait for termination of some of the thread. If you want to wait for termination of the some of the thread which is executing, then at the time we are going to use the function called pthread join. Okay, these are the three different types of pthread functions we are using in POSIX pthread library. Okay, that is pthread exit, next one is pthread kill, next one is pthread join. Okay, so this is regarding thread libraries. Okay, next we are going to talk about implicit threading. See what is meant by implicit threading? Here implicit threading is nothing but if the threads are created and managed by the compiler, then it is known as implicit threading. Okay, if we are compiler, or we can say if the compiler is created and managing the threads, we can say it is a implicit threading. That means creation and management of threads done by the compiler and runtime libraries rather than the programmers. That is, here programmers will not create and manage the threads. Okay, see, we have just now we have studied thread libraries. Now, in thread libraries, programmers only were is going to be created the threads. Okay, here in implicit threading, the programmers will not create the threads. Okay, who will create the thread means the threads will be created, and at the same time, after creating, the management of the threads also done by the compilers, or and at the same time runtime libraries. We can say it is a implicit threading. Okay. In a multi-threaded programming concept, generally we are going to divide the implicit threading as three types. First one is thread pool, or we can say threading pool. Next one is open MP, that is we can say open multi-processing. Next one is GCD, that is Grand Central Dispatch. Okay, next third one is Grand Central Dispatch. See, what is meant by thread pool? See, thread pool is nothing but whenever process execution starts, the compiler keeps all the threads in that process in a pool called thread pool. Okay. At the same time, we maintain the thread pool because it is difficult to create and execute repeated threads. The thread pools is maintained by the operating system. Okay. We can say it is a thread pool. That means we are going to maintain the one pool where we are going to store the threads. Okay. Next, what is a open multi processing? That is open MP. We can say open MP. The threads present in the process create one resource region, one shared region. That region in that region we have threads. Here all the threads are present in the process, which are present is in a shared area. The threads which are cooperative can be executed at a time in open multi processing. Okay, this is regarding open multi-processing. That means here there is one shared region is there. In that shared region, what will contain is in that shared region, all the threads that are contained in the shared region. Here all the threads are present in the process which are present use that shared region. So next one is GCD. See, what is meant by GCD? Here GCD is nothing but we can say Grand Central Dispatch. Okay. Here in GCD we are going to maintain queues for the threads. Okay. Generally we are going to use highest priority queue and a medium priority queue and a lowest priority queue. Okay. Here the threads which are present in the highest priority queue are called highest priority threads. They must be executed first. The threads which are present in medium priority queue are called medium priority threads. Similarly, lowest priority threads are present in lowest priority queue. The size of the three queues is depend on the bit of the operating system. If we are using 32-bit OS, the size of the three queues is 8. If we are using 64-bit, the size of the three queues is 16. The priorities to the threads are assigned by the operating system in a process. Okay. This is the implicit threading models. Okay. So in this implicit threading models, we are going to use three. First one is a thread pool, and the second one is open multiprocessing. Next one is grand central dispatch. Okay. In thread pool, we are going. Whereas if we take the thread pool, we have one area where we are going to store all the threads. In open multiprocessing, we are going to use all the threads will share one common region. Whereas in GCD, grand central dispatch, we are going to maintain three queues, that is highest priority, medium priority and lowest priority queue. Okay. So the threads which are having highest priority, those threads are executed first. At the same time, the threads which are having medium priority, those threads will executed next. And at the same time, the threads which are having lowest priority, those threads will executed later after medium. Okay. So this is regarding implicit threading. Okay. And next one is threading issues. Okay. Whereas if you take the threading concept, we are going to talk about the various issues while working with the threads. Okay, we can say those are the various threading issues. Okay, first one is fork and exec, that is execution system call. Next one is thread cancellation. Next one is signal handling. Next one is thread pool. Next one is thread specific data. So all these are the various threading issues when we are working with threads. Okay, so first one is fork and exec system call. What is meant by fork and exec system call? Okay, generally fork is a system call which is used to divide the threads in the process. Okay, if sometimes you are going to divide the threads in a process, in that time we are going to call the system called called fork. That means fork is a system call which is going to be used to divide the thread in a process. Okay, so for example, if a process may have different threads, if you want to divide those threads, then the time the operating system will call a system called fork. Okay, next one is exec. This is also a system call used to execute the thread. Okay, see, a process may contain different threads. In order to execute all the threads present in the process, the operating system will call a system call called as exec. Okay, here fork and exec. Okay, generally a process may contain different threads. In order to execute all those threads, we are going to use the system call exec. For division of threads in a process, we are going to use the fork is one more system call. Okay, next one is thread cancellation. Okay, a thread which fails after execution has to be cancelled. Okay, if a thread is executed successfully after execution of the thread, definitely it has to be cancelled. Okay, that means a thread which fails after execution, that has to be cancelled. Okay, then that thread is called target thread. That means what is a target thread means a thread which fails after execution. That thread we can call it as a target thread. Okay, there are two types of cancellations. If you take the thread cancellation, generally two types of thread cancellations are there. First one is deferred cancellation. What is meant by deferred cancellation? Here deferred cancellation means when thread cancels, it terminates and gives chance to other thread for execution. Okay, here deferred cancellation in the sense whenever particular thread is cancels, it terminates. Okay, and it will give chance to the other thread for execution. That we can say deferred cancellation. And next one is asynchronous cancellation. See, what is meant by asynchronous cancellation? Here asynchronous cancellation means when a thread cancels, it remains steady without terminating. Then other threads come for execution, terminates this previous thread. That means whenever a thread cancels, it won't give chance to the another one. Whenever another thread will came for execution, and that time only it will give chance. Okay, this is nothing but asynchronous cancellation. We have two types, that is a deferred cancellation and second one is asynchronous. Whereas deferred means when thread cancels, it will terminate and give chance to another thread, whereas in asynchronous it will not like that. When a thread cancels, it terminates without it remains steady. That means it will not terminate. Okay, whenever one more thread will come for execution only, at that time only it will terminate and will give chance to the particular thread only. Okay, so next one is thread pool. Okay, just now we have studied about the thread pool in implicit threading only. Okay, it is also one of the threading issue. It contains a group of threads for execution. That means here it is the area where we have multiple threads. Okay, so next one is signal handling. See, what is meant by signal handling? So signal handling in the sense, signal means a message that is indicating something has to be done. Whenever a particular process is executing in our operating system, then OS handles the execution by sending message called your execution is successful. This is called signal handling. Here handling means roles and responsibilities of the operating system. Okay, next one is thread specific data. So thread specific data means a particular thread uses the data of the process. Here data means global variable, or we can say it is a local variable of a process. Okay, this is a signal handling, at the same time thread specific data. Okay, all these are the various threading issues. Okay, first one is a fork and exec system call, next one is thread cancellation, so next one is signal handling, and the next one is thread pool, and the next one is thread specific data. Okay, this is the threading issues. Okay, so in this class we have studied about the what is the definition of a thread. Okay, at the same time what are the basic types of processes, that is single threaded process, at the same time multi-threaded process and its representation, and at the same time basic types of thread, that is single threaded process and multiple threaded process, and at the same time what are the benefits of multi-threaded programming. That means if you are using multi-threaded process, what are the various benefits. At the same time, what is multi-core programming, what are the various challenges by implementing the multi-core systems, and at the same time what are the two types of threads, basic types, that is kernel level and user level threads, and what are the various how the user level and the kernel level threads are interacting with each other is described by using the multi-threading models. That is, first one is many to one, and the second one is one to one, and the next one is many to many. Next, what is the difference between process and thread. Okay, next one, what is a thread library, what are the various thread libraries. Okay, next one is what is implicit threading, and at the same time what are the various techniques of implicit threading, that is thread pool, open MP, and next one is GCD, and next one is finally threading issues, what are the various threading issues when we are working with threads. Okay, all these are the topics we have covered in this class. So this is the second unit of chapter 1. That is, in the second unit, in this first chapter we are going to learn all these topics. Okay, in second unit, second chapter, we are going to talk about the process synchronization. Okay, in the next class we are going to talk about the process synchronization. That is second unit, second chapter, that is second part. Okay.